So, and then I'll introduce you really quick.
This meeting is being recorded.
So just to introduce Dan Morris really quickly, and I hope everyone's okay if we go, and Dan, would it be okay if we a little bit over because of all the technical difficulties? Sorry about that.
Yeah, it's fine. No problem.
Yeah,
understood.
Okay, cool. So essentially, Dan Morris was one of the early people that I worked with in this space. I was his first ecology flavored intern at Microsoft, and now we actually work together on different projects at Google. Dan has been an amazing champion and leader in this space for many years now, probably close to 6 or 7 years. And he's also been a really steadfast wildlife lover for a long time. And he's going to be giving a machine learning flavored perspective on the question, how can AI help my conservation project? And I'm really grateful, Dan, for you to take the time. And I don't know, I'm going to see if I can set up so that you can actually see the room. So I'll work on that while you start talking.
Sounds good. Sounds good. Hi, everyone. It appears that you can't see me, but given the technical difficulties we've had, I think we're going to call it a local maximum for now and not try to fix that problem. But there's pictures of me on the internet. I look like a pretty vanilla white guy with short hair, so you don't really need to see me anyway. So we're going to talk today about, this is going to be not a super technical talk. This is sort of going to be like a little how-to guide to how you might, getting a little feedback, something fun going on over there.
Oh, we are going to get, is it from the, are you still getting feedback? Do you hear it? Like, I hear this, but this has been going on. No, there's like a,
Yeah, I hear the.
it's been like that. So we are getting a little bit of feedback. I don't know how obnoxious it is for you. For us, it's pretty subtle. I don't know what's causing it.
Right now, it's fine.
Much better.
Okay, sounds good.
Anyway, starting over, we're going to talk about, like I said, not a super technical talk, not talking about, there's going to be like no network architectures in this talk. This is going to be more about how you might think about approaching new AI for conservation problems, especially ones that aren't your problem. When you think about you as you're going to finish this CV for ecology course and you're all going to be deputized to be conservation technology champions out there in the world, and all your colleagues back at your home organizations are going to ask you about their AI for conservation problems. And hopefully the goal here is to get you thinking about how you might efficiently run those kind of conversations so that you can point other people in the right direction too. And conceptually, please do shout out with questions, although right now I can neither see you and I don't know if I can hear you, but in principle, shout out if you have questions. Okay, so more specifically, what we're going to be, I can hear you, Sarah. I don't know if anybody else is talking.
Someone else want to say something?
Hi, Dan.
Hi.
Can you hear us? Okay, great. So yeah, you can actually shout out questions.
Please do. Yes, yes. Okay, so specifically what we're going to talk about first, when I say AI for conservation, I actually mean a pretty narrow subset of AI for conservation. So maybe some useful taxonomy to help you make the same distinction I do and understand where I'm coming from. And then we're going to get into that hypothetical conversation with an ecologist who wants to try AI for conservation for their problem. And hopefully in a few weeks, you'll all be in that position of having that conversation with fellow ecologists out there in the world. Then we've got a couple optional bonus topics if we have gobs and gobs of extra time at the end, but not too worried about that. Okay, so when there are people mean lots of different things when they say AI for conservation. I mean something pretty specific, and I don't want to tell you that like that's the one true AI for conservation. I want to kind of give you a taxonomy of how I think about it, maybe help you put different problems in different boxes so that you can use that taxonomy also. So when I say AI for conservation, even AI, of course, people could mean just about anything in the world when they say AI right now. So I'm going to kind of break all of AI down into two convenient categories for this conversation. So it's kind of an AI for data processing type of problem. In this picture, find all the cars in this picture and put boxes on them. These are things that people in AI are both pretty good at in 2023. This is also the kind of task that people find very boring, and conveniently, AI has not yet complained about finding something boring. And people are also finite, whereas AI isn't. So if you have 50 million images like this from a traffic camera, you will run out of people to put boxes on those cars, but you more or less won't run out of AI. That's kind of one kind of AI. The more ambitious kind of AI on the right here is AI for kind of higher level decision making, and I'll kind of put forecasting in that category. So this is still the kind of thing, as much as we want to think that AI is getting really smart, and it is, this is the kind of thing that people are still much better at than AI. This is also the kind of thing that like people go to grad school to learn how to do, and people generally find this interesting. And this is also, these kind of decision making and even forecasting problems aren't the kind of things that really get better with more workers, whether human or AI. So an infinite number of people don't really make decision making tasks any easier. So kind of all the AI that I work on and all of the things that I mean when I say AI for conservation is really helping AI practitioners do as little of the stuff on the left as possible so they can spend their hard-earned time doing the kind of stuff on the right, the higher level decision making. So what am I not meaning when I talk about AI for conservation? So I'm not really talking about like recommender and planning systems, like AI to help you decide where you should plant your trees or which land you should protect. And I'm also not talking about AI for forecasting systems, like under a particular climate change scenario, how will the population of some species change? Another way of saying this is that I'm talking about AI tools where we know what the right answer is. It's very hard in these other kind of problems to know clearly what the right answer is. And I'm not telling anybody not to work on these kinds of problems. These are all really interesting problems. I would say go into these with eyes wide open because they tend to be very difficult to show when you're making progress, very difficult to translate into practice compared to the more data processing kinds. But these are things I don't mean today and don't really even know that much about. So mostly what I'm talking about is the data processing kind, which is really, I think, the kind where we've had the most success so far in AI for conservation. Another way of looking at this, of course, is that all of the things I talk about on this slide, all of these recommender planner systems, humans are still really better at these things than computers. And so I focus on using AI for problems where we basically know the right answer, and we could train a hypothetical army of humans to do this task. So, and by having AI help us with this, we let humans and organizations focus their time and budget on the bigger picture stuff. And in particular, this tends to fall out as things like reviewing sensor data and processing lots and lots of boring documents. These are great opportunities for AI to accelerate you. The next couple of slides are going to serve two purposes. I'm going to give some examples of what I mean by this. This is also my like sort of backhanded way of sneaking in a bunch of things that I work on so that you think of me when you want to ask questions about these things and you know some stuff you can ask me about. And like throughout your CV for Ecology course, I'm happy to answer questions about any of the things that I sneak into the next 4 or 5 slides. So Sarah and I have both done a lot of work on AI for camera trap surveys, and this is like the canonical problem of like, we know exactly what the right answer is when we look at problems like this. I'm only a little confused because my slides are changing and something happened on the screen that I'm seeing on your side that is not changing. Sorry?
Oh, no.
Did
Sorry.
something, whatever.
We were trying to change the camera and so you can see the room, and I think we messed something up.
It's okay. Technology is complicated.
Okay, one sec. I'm so sorry, Dan.
No
you're
problem.
Our first talk. You're our first
I understand.
speaker, and inevitably, this room is fighting with us. All right.
This is the only time in the history of Zoom calls that there have been technical difficulties. It is totally your fault.
Can you try and advance your slides, Dan? Is that so? He's one slide out. Oh yeah. Okay. Yeah. So I don't want to share my. Nope. This one. Okay. Oh, that did something. No.
Laminated instruction thing.
You can try. That thing is not very helpful. Okay. Go one.
Anybody?
No, there's this weird. Wait. I think essentially it thinks that someone else. Yeah. Can you just Can you just try and can you unshare and try and share your screen again, Dan?
I sure can. Yay.
That looks right. I think it just needed. Cool. Yeah. Great.
We're back.
Thank you. So sorry.
Hi everybody. No, it's okay. I'm happy to be guinea pig. So we were back to AI for boring data processing tasks, helping people spend their time on interesting things. Kind of the canonical example in this space that Sarah and I have both spent a lot of time on is AI for camera trap surveys. There's maybe nothing clearer where it's like, we know what the right answer is. There is an animal in this image. Let's use AI to help people be more efficient at this process. So Sarah and I have both worked on a platform called Wildlife Insights. That's a platform for camera trap data management that has an AI component. And Sarah and I have both also worked a whole bunch on a model called Mega Detector that helps find animals, people, and vehicles in camera trap images, mostly so that those well-trained humans can spend their precious time on the animal part and not on the empty and people part of their camera trap data surveys. But camera traps are like nearest and dearest to my heart and maybe to Sarah's, but of course this problem of like, we have a whole lot of data, most of it doesn't really need human attention and isn't that interesting, is not at all unique to camera traps. There's a very similar data distribution in acoustic surveys. If you go out and put hydrophones in the ocean for a really long time to survey whales, you're gonna get some whales, but you're also gonna get a whole lot of waves crashing over the ocean that isn't very interesting. So there's exactly the same opportunity without totally solving the whole problem to help people spend their time on the interesting stuff rather than the boring, empty environmental noise. Similarly, for aerial and drone surveys, which look really interesting when you look at pictures like this, where, oh, it's like somebody flying a plane took a picture of some geese on the ground, but actually somebody flying a plane took a pictures of miles and miles and miles and miles of empty landscape, and I picked the interesting ones that have birds on the ground. There's another huge opportunity for AI to help people spend their time on the more difficult tasks, like species classification, which tends to be very difficult in aerial and drone surveys. And this field, for what it's worth, is just really taking off. Camera traps have been at it for a while, so AI in this space is really just taking off right now, but overall the data distribution is about the same, maybe 95% boring emptiness, and we can really use AI to help people focus their time on the stuff that humans are still better at than AI. And then lastly, really everything in the mapping category falls into this space too. As you all probably aware, there's lots of folks using AI for a whole variety of mapping tasks. One, for example, that I've been spending a lot of time on at Google is mapping urban forests from the same aerial imagery you see in Google Maps. And all of these fall into the same category. It's literally the same imagery in Google Maps. So a hypothetical urban forester staring at Google Maps could theoretically click on every single pixel of tree and get exactly the same results or better that our AI can produce, but humans don't scale quite that way. And so there's a huge opportunity here to accelerate what urban foresters do and let them spend more time planting trees and less time counting trees. One thing I do want to also squeeze into this part of the talk, in all of these spaces, AI is never perfect. In fact, it's never even as good as AI papers say it is. AI always makes mistakes, and so we're constantly need to work with users and experts to understand what those mistakes mean for real applications. And along the same lines, AI is really only useful in this space. Really, the way AI leaves academic papers and makes it into practice isn't getting better. It is almost never like AI was confined to academic papers for some task because it was at 92% accuracy, but then somebody got it to 93.6% accuracy, and now the field could really use it. Almost always that translational gap is about tools and workflows that know how to use AI. And I think this is also the place where I've seen the most AI projects fail. It's very easy, especially for machine learning folks, to really get hung up on the AI part, kind of assuming that the AI will be perfect, in which case the workflow is almost always very simple. But in fact, AI is never really perfect, and people have some workflow they've been using for years, maybe decades in their ecological domain. And it is at least as important as that next bit of hyperparameter tuning is to really think, okay, I run this AI model and it like produces some JSON file somewhere. What happens next? Do I need to do some engineering? Do I need to find a way to load that into the user's workflow? Is it worth it for me to convince my user to actually learn a whole new set of tools? Because AI will be so much more efficient that it justifies that learning cost. These are tough problems, and I think the ones that cause the most AI for conservation problems to get stuck at that academic machine learning stage. I'm going to pause there for a second. That was my whirlwind, maybe even like double whirlwind tour to try to make up for some technical time. Pause there for a second and just like see if any questions about, not so much about the specific projects, but more like, are we all calibrated on that kind of taxonomy of there's this universe of AI where we know what the right answer is. We can help people accelerate their tasks. That is a very mechanical use of AI that is mostly what I work on. There is a whole different world of AI for conservation. I'm just making a taxonomic difference between those things. I'm not saying one is better. I encourage everybody to, like, especially if you're working in that latter category of AI for forecasting or higher level decision making, those workflow problems get even trickier there. So go into those problems eyes wide open. Any questions about that part one tour of what I do, taxonomy of AI for conservation? Going once, twice? Okay, let's go on to part two. So now this is the part where I'm sitting down with a hypothetical ecologist who comes to me and says, hey, I've heard about this AI thing. I have some boring stuff that would really help me out if I had infinite amount of time. Can AI help my project? And not really thinking, many of you are often running on your projects right now. I'm using this part of the talk less to guide you about your problems, more to give you some thoughts about you're going to all be in this role soon. And part of the reason I think you all take this course is not just get better and solve your problems, but to learn this space in a way that you can be that consultant for the next ecologist down the line. And hopefully, Sarah and I have been through this kind of conversation between 7 and 8 zillion times with ecologists and have learned some questions that we ask right away that really help us zone in on getting people pointed in the right direction. I'd like you to all start thinking about the kind of questions you would ask and how you can sit in that role as well. So the assumptions for this hypothetical conversation I'm having with an ecologist is that all the projects we're talking about are in that category of basically data processing. We're accelerating a task a human could do for purposes of today, and we're starting a brand new AI project. I'm not really that interested in questions like, I'm 99% done and I want some advice on hyperparameter tuning to, like, make my model a little bit better. That's not really what we're talking about here, and I essentially never get questions like that from ecologists. It's usually much more like, I'm just starting my AI journey. I have a hunch that AI can help me. Where do I get started? And importantly, should I get started? So the goals for this hypothetical conversation that you are all going to have with lots of ecologists after the summer, you might be able to give somebody next steps to try, like really go try this model, you maybe tinkered with this architecture and now tinker with this architecture instead. A much more typical case when somebody comes to you for the very first time and is like, I would love it if AI could help me with that problem. Their problem is typically not that well defined yet. They're not doing anything wrong. They're just new to AI and new to AI terminology, and maybe their problem isn't that well defined. And so typically what I try to do in one of these conversations the first time is basically to give them a little homework that will help us better assess whether AI can really help this problem. And 9 times out of 10, that homework is understand the size and distribution of your data and collect some representative data examples. And we'll talk about that a little more in a second. And then, of course, sometimes the outcome of even this first conversation is like, AI isn't worth it for you. And this is another, like, really good mode to be in. It's very tempting as an AI for conservation enthusiast to get into that mode of, like, every problem could benefit from AI. Very often the most helpful advice you can have for an ecologist is that, like, it would take you 700 hours to build an AI solution for your problem that will save you 40 hours, and it isn't worth it. And so we should all be, when we're having these conversations, we should all be in that mode of asking not only what is the best architecture or best AI strategy here, but is AI really going to be helpful here? And also advise everyone, I give very different answers when it's like a student who just wants to learn about AI. In that case, AI isn't worth it is almost never the right answer. But for real conversations where somebody's trying to really solve an ecology problem, very often, maybe 50% of the time, the right answer is either you're asking something that's impossible from AI, or AI could do this, but it would take more time to build that system than it will take you to just go through your data manually. And we all want to kind of be calibrated to that so that you can give the most helpful advice, not just the most AI-ish advice. So again, the rest of this part of the deck at least, is kind of the questions I would ask you if we were having that conversation about your AI for conservation problem. So almost always the first set of questions I ask is really just trying to understand the problem. People often, if they say, hey, here's a picture of a thing I want to find in satellite imagery, they very often send you the most interesting example. That may be the easiest, it may be the hardest, but often it is almost never a totally random example that they've given you in that email where they asked you about AI for conservation. So always really try to get an understanding of the distribution of the data. How much of it is really easy? How much of it is the classes you're trying to find? If somebody says, hey, can you help me find wells in satellite imagery, and they show me a picture of a well in a satellite imagery, I want to ask a question like, how big is the area you want to search for those wells, and how many wells are there in that area? Because they'll almost always give you a picture of a satellite image with a well. It's important to know that that's literally 0.0001% of the images, or maybe they're searching a small area and it's relatively, they're actually relatively well represented. So really understanding the distribution of the data and not being tricked by the first couple of examples you see is a really helpful first set of questions. And then always ask a lot of questions about if this is a task they have already been doing to some extent. What tools are they using right now? Like literally, what do they have open when they're annotating this data that they use? Do they have an Excel spreadsheet open while they're paging through satellite images? Do they use some existing annotation tool that they've really invested a lot of time into and we kind of want to keep using it? Ask a lot about how much data they have to process. And usually I'll ask something, if you show me a satellite image, say I want to find X in that image, I'll ask, well, how many more images are you going to have like that in the next year or 2 years? Sometimes I'll ask, how many do you have right now? But again, to this question of, is AI worth it? It's really helpful to know, do you just have one pile of data that you basically need to get through once to finish your PhD thesis? Or is this the beginning of this is something you've been doing every year for 20 years and you do it for 20 years more? That really changes the equation about how much effort it's worth putting into an AI system. And of course, most importantly, always ask for sample data, representative sample data. So some easy data, some hard data, some in the middle. If there's lots of empty space in this hypothetical pile of satellite images where they're looking for wells or whatever, make sure you get a whole bunch of the images where there aren't wells, ideally selected kind of at random. So get sample data in front of your eyes, especially for computer vision problems or text processing problems, as soon as you can. Also ask lots of questions about the team that you're working with, because sometimes, again, the right answer isn't just about technology, it's about the level of investment that team would have to make to bring AI into their lives. And sometimes this does come down to what level of machine learning expertise, although even more often, like what kind of non-machine learning technical expertise they has. Do they have an IT staff? Do they have a software developer on staff? Do they have maybe a GIS person? Do they have a person who knows Python? Because again, some of this will affect like the literal mechanics of a solution. Do we want, maybe there's an off-the-shelf model that works, but somebody needs to go wrap it in R for them. But often it also, again, impacts this question of like how much skills development would they have to do to solve the problem with AI, and how does that weigh in on whether AI is worth it in the first place? And then oftentimes, I might be getting an email from an ecologist who's asking about a problem, but it's not literally the ecologist who's going to use whatever AI tools we talked about. It might be, again, a technical staff, a GIS analyst on their team who's going to be actually using those tools. And it's really helpful basically to be put in touch with that person as soon as possible so that you can get the clearest answers you can to some of these kind of mundane questions about technical expertise and resources. And then lots and lots of questions about data. Of course, if we're talking about a traditional supervised learning problem, always ask, how much data do you have right now that's already labeled and at least kind of AI ready? Are you sitting on, I don't know how I landed on this wells and satellite images example for today, but let's go with it. Are you sitting on like, oh, I have 50,000 wells with clearly defined points on them, and I have the satellite images all well organized in a directory somewhere? Or is it like, I've kind of just got started with this problem and I don't really know what training data is yet? So really understanding the distribution of the data, both annotated and unannotated that they have, and then kind of try to feel out what's the cost for getting more training data. Because very often we'll come to a problem that it's like, oh yeah, AI actually is worth it here, and this is a totally tractable problem. You have 50 examples and we need 2,000 examples. What's the cost of getting those other 2,000 minus 50 examples? And again, sometimes this is a deal breaker. Sometimes this makes AI not worth it, but really understanding who would do that and what the cost is and like what their appetite is for collecting more training data is important to understand at this stage, even beyond the technical questions. And then always be cautious about when somebody says, oh yeah, we have lots of data, or here's some sample data, really try to understand whether it is really going to look like the real data they want to run their hypothetical AI system over. And sometimes this can be very subtle. Oftentimes you'll have, oh yeah, we have data from a prototype camera we built a few years ago. We want to train a model, and then we're going to use it on this pretty different camera we want to deploy in the field next year. It's not a deal breaker out of the gate, but it is really important to understand and to make users aware that AI models are not known for great ability to generalize, and it is really important to ask if there's going to be significant changes in that data distribution, how big is it, and how can we best plan for that? This one's a little less important as time goes by, but always ask, like, if we if AI can solve your problem and find all, I don't know, your bears in your camera trap images or your whales in your satellite images, at some point we want to figure out if we train an awesome AI model and it's totally worth it, how will you mechanically run it in the future? Do you have someone on staff that can run it if it requires GPU resources to run it? Are those available? Do you need to have? I often find, by the way, I do encourage ecologists very frequently, if a model is effective and is literally a lack of Python expertise and GPUs for running it, a good trick I found is that, especially for academic ecologists who work at a university, I always encourage them to like buy a latte and a cookie for their neighborhood computer scientist, like undergrad or student, for whom this would be like running that model on their GPUs might be the most interesting thing they did that day. And it is a totally reasonable thing to suggest, like, rather than going and buying GPUs for your lab, if you're at a university, there are GPUs around somewhere. And it's totally reasonable to like find a GPU friend to help run that model in the future. Although I have to say, I'm thinking about this in real time, even since I made this deck like a couple years ago, this slide is increasingly not as relevant. GPUs are so much more widely available than they were even 2 years ago. They can't buy a mid-range PC from Dell now without a GPU. And the just basic command line and Python literacy of ecologists has gone up so much in the last 2 to 3 years that like this is really not a deal breaker in almost any case that I've seen before. If you can get an AI model trained and it really solves a useful problem, this is an important mechanical question, but it doesn't really factor into the like, is AI worth it in 2023? And then, of course, to the extent that this isn't a totally brand new problem, have you actually tinkered with maybe some non-deep learning stuff? Have you tried out some early deep learning stuff? What have you tried? Where are you at in your problem exploration so far? And then again, kind of revisiting a theme from before and super, super important, if we solve this AI problem and we can find bears in your camera trap images with 93% accuracy, or we can find whales in your satellite images with a precision of 0.9 and a recall of 0.7, what will you do with that model? And again, this is often the place where AI fails to translate to practice. And unfortunately, it often fails to translate to practice after somebody's spent a lot of time building that model. And it's really helpful. It really does set the guidelines for the accuracy you want to get to, and really thinking through how you would integrate an AI model into somebody's workflow, assuming the reality that AI isn't perfect. What will you literally do with the output of that AI model, and how much time will that save you? How much bigger an area can you conduct your survey over, whatever the actual outcome is, and really ask, like, even if the AI goes great, is this going to be useful, and what will you do with it? And this is, like I said, the most often forgotten aspect of an AI problem when starting from scratch. And so then kind of like once we start to get all those answers from our hypothetical ecologist, we're trying to answer questions like, is this problem possible with AI at all? And what kind of accuracy might we expect? As you all go through this course and spend more time with deep learning, you kind of get a sense for like what especially computer vision can do and what it can't do. And you'll get a good sense for like, is this a completely impossible problem? Is this a super trivial, you'll have 100% accuracy problem? So what kind of accuracy might we expect? And importantly, as you hang out with all the other folks in that room and other folks in the field, you'll start to have a sense of what other problems people have already worked on. And so, of course, an important outcome is like, has somebody else already trained a model that would be really useful for you? It is really rare that somebody has trained a model that will completely solve your hypothetical ecologist friends' problems right out of the box. I wouldn't say never, maybe, but it's pretty close to never that it literally solves the whole problem right out of the box, and they don't know about it already. It is rare that someone has trained a model and it is surprisingly rare that someone has trained a model for a similar task and you want to use that for pre-training. This is very tempting to say, oh, somebody trained a model for leopards and you're trying to find jaguars and maybe we can use that for pre-training. So like maybe a topic outside the, like, we can do this in Q&A or talk about this more later, but the TLDR here is like, pre-training on somebody else's model is really tempting and is rarely as glorious as it seems like it will be. So we can come back to that, but this is actually also a relatively rare scenario. It is very common, though, that somebody else has good advice on the problem, good training tools. Even if you start from scratch for the training, they may have good training tools or good tools to like convert the output into some other useful workflow tool that your ecologist friend is using. So there's a lot we can learn from somebody who has worked on similar problems, even though I will claim it's relatively rare that somebody else's model weights literally work right out of the box. And then it's always nice if you can solve this problem, if putting a solution out there into the world would actually help other people with similar problems. And this maybe is somewhat more relevant for like you in this room who are pretty technical than maybe the hypothetical person you're having this conversation with who kind of just like wants to get through their problem. But it is always a nice bonus if you solve a problem and it's beneficial to the community. And then at the end of this conversation, sometimes maybe 30% of the time when I have a conversation like this, I try to be honest, like AI is not really going to help you that much, or it could solve this problem, but it's totally not worth it. So still do it if it's really interesting and you want to learn about AI. That's always great. There's lots of reasons to do that, but we always want to have our eyes open to the fact that AI is often not that helpful when people think AI might be helpful. Sometimes there's a totally off-the-shelf tool you can use, and the more you know about what's out there, the more you can give people advice that like, hey, actually, yeah, you might, if you trained a custom model, it'd be 10% more accurate, but it's so worth it to not train your own model that if you use this off-the-shelf tool and it's a little worse, then that's a good solution. Also, when I'm talking to folks who don't have previous deep learning or machine learning expertise, I often do advise people also, before you go do anything fancy, try a no-code tool. There are 50,000 no-code tools out there. Google, Amazon, Microsoft all have enterprise no-code tools, especially for computer vision. There's 1,000 startups that have no-code tools, and they're so easy to try that it's, especially if you get the sense that, oh, this problem isn't that complicated, it's kind of a vanilla machine learning problem, especially a vanilla computer vision problem, always encourage folks to try tools like this first. Often, sometimes it can solve their problem. It also really does help build up some just fluency and experience on the ecologist part of like what a training validation split is, what is easy and what is hard. What are the, just like, what is it like to try machine learning, even if it doesn't work? And the bar for trying it is usually pretty low. So if it's even vaguely on the menu that it might do something useful, I do encourage folks to try no-code tools first. And for all of you, even though you're going to do some custom deep learning for the work you're doing this summer, I do recommend like also try some no-code tools so that you can have that experience and so that you can know in some sense, like it's like, you may learn a lot from training a custom model, but it's really useful to know whether you basically would have gotten the same results from a no-code tool. So encourage everybody to at least have those in your toolbox. And then maybe 30% of the time, it's like, yeah, actually you've come to me to ask about an AI problem. I think it's worth your time, but it's a new problem and you're going to have to train a model, or we're going to have to train a model, or we're going to have to rally the AI for Conservation Slack to train a model. So we talk about next steps about how we get from point A to point B. I bet Sarah's already pointed you to all of these resources, but for what it's worth, check out Wild Labs, check out the AI for Conservation Slack, and I host a whole bunch of data at lila.science that you can all tinker with. The only thing on this list of URLs I will point out, so that last link about camera trap questions, I'm not, yes, I do want to talk about camera traps all the time, but that's actually not why I'm including this link here. We have, so because Sarah and I have worked a lot on camera traps, I get emails about AI for camera traps a lot. And it has been really useful to distill the first set of questions that I asked those people into basically a form. It's actually a list of questions on GitHub, but it's basically a form where 99% of the time, if people just answer those questions, I can really get them pointed in the right direction about whether it's worth using Megadetector, whether it's worth training your own model, whether it's worth even bothering with AI. I'm encouraging all of you to maybe think through, for problems like yours, what's that template that you'd like to have, so that if, in the best case, you become an expert on this and 50 people start asking you about camera traps or finding wells in satellite imagery or tracking geese in videos, whatever it is, what is the set of questions that would really help you boil down best the device very efficiently? And we've had really good luck with that relatively simple set of questions. So I kind of just encourage you to come up with that template for the kind of problems that you're working on. Oh, and yes, another plug for Lila. And I will basically stop there. I have an infinite number more slides to talk about on the optional topics, but I think this is a good time to maybe stop and flip over to Q&A. I'll follow Sarah's lead here, given our kind of surprise trajectory for our hour today.
Thank you, Dan. Sorry again for all the technical difficulties.
Bring it on.
Any questions for Dan about some of these different dimensions? And yeah, who has questions?
Sorry, I guess I'll start. So I think your point you sort of brought up earlier about a workflow being AI aware was really great. And making a workflow be AI aware, I feel like is a fairly multifaceted problem. Like you're going to have to deal with the sampling protocol, maybe dealing with hardware or software, and then actually training the model. And I've found that, at least in ecology projects that I've worked on, a lot of like dealing with those problems is sort of delegated to one or maybe two people. And my question is, if you're making a workflow that is AI aware, is it sort of useful, or have you found it beneficial to have a sort of team where specific people are sort of delegated to each of those smaller problems within making the workflow AI aware? Or is it actually better to just have like one or two sort of AI people that are sort of assigned to that task broadly?
That is it. Yes, there's definitely a really interesting discussion to have there. I will start by saying I actually meant something a little more mundane than that. So let's come back to the bigger picture question, because at one end of the spectrum, there's make your whole process AI aware, where again, I'm gonna just exclusively use camera trap examples here. Sometimes I try to diversify, but I'm not going to right now. There's one extreme is like, think about AI throughout your whole process, which might at one extreme mean I might place the cameras differently so that AI works better on those images. That's actually not really what I meant there. That's sort of the extreme of like, be AI aware in your entire project. I meant something even more mundane, which is like, if you were using a tool before to review your camera trap images, where you always went through them from beginning to end in chronological order, just because that's what your tool supported. Or you actually, a lot of people, for example, maybe still most, but certainly a lot of people review their camera trap images by opening them up in the Windows Explorer. They're sorted chronologically, and they have an Excel spreadsheet open on one side, and they're going through the images and annotating things in their Excel spreadsheet as they go. There's nothing fundamentally wrong with that, but now I give you a model that has AI results. Now you have a CSV file somewhere that has AI results in it. That workflow has no way of doing anything, like no way of getting, unless the AI is literally 100% accurate and the workflow disappears, that process has no way of using AI. That's actually the more mundane step that I meant. And so, for example, sometimes that's, most of our mega detector users, for example, use a camera trap data review called time lapse. And when I say making the workflow AI aware, I meant email the time-lapse developer and help them load the results from your AI model so you can do things like sort by animal confidence. This is a much more narrow version of that, but if you had just used your previous workflow and it just didn't really know anything about AI, it wouldn't have gotten any faster. Now we went through some mechanical steps to load that data. And then similarly, even aside from the mechanical, there's kind of like some guidelines. So we also run, sometimes we'll run a species classifier on somebody's camera trap images, and it's not perfect. It might not even be good, but it can be helpful if it helps you, instead of looking at images by totally randomly by species, if you can basically look at all the deer in a row, even if you are still going to look at all the images of animals, that can be really helpful. But again, the tool you're using has to have some way of doing that. And you have to have like some best practices written down somewhere so that the user knows which buttons to click to go through all their deer efficiently. These are really kind of mundane mechanical questions, but they're ones that people forget about a lot. Like, it doesn't really matter if that AI model was literally 70% accurate or 95% accurate. Unless that's good enough to use with no review, you have to go through this step of figuring out literally how do I use the results in my workflow so that the workflow, the literal tools are AI results aware. Maybe that would be a more accurate way of putting it. And I think you can all, in your own workflows and the problems you're working on, can kind of imagine what that work would be and where that workflow might break down. And again, it's great if AI completely automates the process and the workflow totally disappears, then all these questions go away, but that's pretty rare. So I encourage you all to think like, literally, what changes do I need to make to the tools, to the process? Do I need to like, just like data format conversion kind of stuff? That's kind of really the boring stuff I meant by AI aware. So I actually couldn't see the person who answered that question, but I'll now ask the question back to you. Did that satisfy you, or do you want to go on to some of those higher level questions that I think you were getting at?
No, actually, that I think really helps me better understand, exactly what you were talking about. Being AI aware, and I think at the very least, I'll have to give some more thoughts to what you just said, but before asking another follow-up. But thank you.
Awesome.
Dan, you had a question?
Yes. Hi, Dan. Thank you for the talk. I think I've sat on a call with you before where you've given a project a rundown of all these questions. So it's great to see why you asked those. And I'm interested in the auto ML tools because I've read a lot about them. I've not really tried them, but I think when you see ecology papers, there's not many using them, and whether that's because they're kind of too new or they've not worked well, or people are choosing impact with kind of creating new custom things. So do you think there's actually more that could be done in that space to use those, or why they're not being used as much?
I think that 80% of the time, maybe 90% of the time, the auto ML, the no code tools actually won't work well enough for the kind of problems that the people in this room are working on. That is to say, I think it's not, yes, there's a tendency for machine learning people to like want to learn and try more experimental stuff and write papers about machine learning. So there's maybe a little bit of a bias away from using off the shelf tools. But actually, I think that most of the time that ends up being the right thing. Like those tools are good for problems that are relatively easy. And a lot of the problems that we work on are not, just like in terms of computer vision, are just not that easy in the grand scheme of computer vision problems. Again, they really are worth trying because it's such a win when they work. Like species classification, actually, so for an example, like now, I actually bet that a lot of the like iNaturalist type image classification that's relatively well lit and relatively well framed compared to even 5 years ago, a lot of no code tools would do really well on a lot of those images. But on more difficult problems, on domains that it's never seen before, like acoustic classification, those no code tools generally don't work on the kind of problems that we're working on. That's why I think you do want to build up a sense of like, if the prior is those tools are 10% likely to work on some of the problems we're working on, if you kind of build up a sense, if you try them a couple times and you build up a sense of what they can and can't do, you'll have a, like, if you come across a problem where they're 30% likely to work instead of 10%, it's worth trying because the benefit is so high of now the ecologists being able to basically do the whole process themselves and not be reliant on a data scientist or machine learning person who might be temporary. So that's why it's really worth learning their capabilities. But in general, it's not really people wanting just like reinventing the wheel for reinventing the wheel's sake. They really are limited in what they can do. In just like they just don't they don't bring any domain intuition that you do to the problem, and they're somewhat inflexible. But getting better by the day. So maybe my 10% is even out of date. Maybe 20% of the problems that we kind of work on, actually some of those no code tools could be really helpful.
I think one of the biggest bottlenecks is actually like data processing tends to be like the sort of standard set of like the processing of input data. Like there will be some like weird default things in these no code tools that are often difficult to change that are assuming things like normalizing the red, green, and blue channels a specific way based on like internet imagery that sometimes do really weird stuff to something like an audio spectrogram. So there's like some just weirdness sometimes in those tools. But like Dan said, like they're becoming more flexible. The challenge is with the no code stuff, it's really hard to build a really flexible GUI that will solve everyone's problem all the time without making it so unnecessarily complicated that it's like almost impossible to actually use. So we're sort of forced to make choices based on like common problems, which tend to, in machine learning, most of the time, be like problems on images that people upload to the internet, which there's some differences. But there was an example, Dan, like I talked to one woman who was using Megadetector, taking the crops from Megadetector, and then they had like 10 Nest cameras. And she just wanted to know, like for these 10 Nest cameras, like, is this crop of an animal a bird or not? And she like didn't actually have to use that much data. She used a no code tool, and it was again that version of the I want to label all my data and I only want to actually use human labels for some of it. So it was all IID. And she was so happy. She was like, it worked perfectly. I'm thrilled. Like this is the best thing that's ever happened. So like, there definitely are these instances where you can get a no code solution that really solves your problem. But is this a bird or not? And like 10 Nest cameras where the bird's quite close to the camera, there's not that much variability. Like there was a lot of sort of constraints of that problem that made it tractable with an no-code tool. Any other questions for Dan? Do you have a question?
Yeah. I just have a question about terminology. Not to get into a whole discussion about definitions, but you use the terms like AI, machine learning, all of these in your talk. And I'm just curious, like, I guess specifically as ecologists, like how can we be better about using the right terms? And like, get like finding literature or using the right terms in our papers so that they're, I don't know, like you also alluded to AI, like you can say AI, anything is AI basically these days. So I'm just curious your thoughts on that.
That's a good question. I used to, this is causing me some deep self-reflection. I used to basically never say AI. It wasn't really judgmental. It was just like imprecise. And so I said machine learning, which is almost always what I meant. And I think that AI, the term AI, has been so captured in the zeitgeist that typically when an ecologist comes to me, if I respond and I just start saying machine learning, it actually is like a little awkward because like AI has so become such a familiar term that nobody even asks me, can machine learning help me? They say, can AI help me? So I think there's just been kind of a zeitgeist terminology change. At this point, I'm a little sloppy and I basically use them interchangeably now. Good question. I don't have a good explanation for why that is. But if you like, now I'm looking at the title of my own talk and I'm like, oh my goodness, I said AI. I wouldn't have done that 3 years ago. Not really, again, not out of judgment, just like it was just imprecise and I didn't even really know what AI meant. Now it's such a standard term that I use it interchangeably with machine learning.
I also think that people in machine learning just don't. There's no consistent use of these terms. I would just not read too much into whether someone says AI, machine learning, deep learning, computer vision. Like, it's all just like weird, flexy. Just assume it all kind of means the same thing.
I do. Like, the one thing that does raise another point. So that was specific on the AI versus machine learning. I'm pretty agnostic and kind of use them interchangeably. For folks who are new and are not familiar with the terms computer vision or more often deep learning, that is one where it's often helpful. So like not head like AI. Take this with a grain of salt, but here's what I would say when somebody asks me to decouple these terms. I would just say AI and machine learning are the same thing. Deep learning is a subset of that thing, like a specific subset. And I don't even usually get into the like architecture question. It's like it's the subset that can do powerful things but needs a lot of data. The rest of machine learning is like stuff you kind of would have called statistics a long time ago. Like linear regression to me, anybody who's asking me this question has typically done a linear regression in their life. And to me, like that's a great example of machine learning that isn't deep learning. And that usually helps people. I don't get too into the subtleties of what a CNN is, but it's like deep learning equals needs lots of data, but can do big things. Classical machine learning like includes linear regression. Everybody's familiar with that and is very limited in what it can do, but doesn't need nearly as much data.
Maybe one last question? Yeah.
Hi, Dan. So I think I'm looking for more of a motivational speech right now from you. And I'm going to tell you a personal story as fast as possible. I work with a team of pollination ecologists. They hired me as their art programmer, and now they send me to learn AI and bring it to the team. And many people in the team, when they join it, they come with the idea to save the planet, save the bees, you know? But when you actually start doing that, you have to focus on the rare species. And you don't, often in AI, you don't have enough images for the rare species. And how do I keep my motivation? You know?
I am not going to try to give you an answer about your motivation, or like, I guess we can talk about that, but that would be like, we can talk about our hobbies and like learning new instruments. I will give you a slightly different answer though, which is like, that is a typical problem. So the first question I ask there, like, are we sure we need to do species classification, or is there a part of that problem that AI can help with? Like, again, the analogy to camera traps, like it's so people instinctively want AI to solve the whole problem, or at least they want to try. Sometimes that's the right thing. Sometimes that's actually like going to lead you down a tough road for exactly the reasons you just highlighted. So if that's a case where they're taking, I'm just making up a scenario, but they're taking pictures, if it's image-based and a lot of the images are empty, maybe just focus on that. And if it can save you 90% of your time, maybe it's disappointing that you don't get to the species classification, but like maybe that's worth it. And then on the species classification side, it's like, well, if the rare species are tough, we're gonna get into like, this is more like, now we would go down the road of actually having that hypothetical conversation, but like sometimes there's a scenario where rather than focusing on the accurate, you know, sometimes when you train a machine learning model, like 99% of the time we train to optimize for accuracy. You can train a little differently to optimize for somewhat more reliable confidence values at the cost. Nothing's for free. but you can train for somewhat more reliable confidence values at the cost of accuracy. And maybe that's a case where you want to like pay a price in accuracy so that you can take all the high confidence examples of the common classes, not look at them, and now have a smaller amount of your time that's going to leave a bunch of common. You're still going to be overwhelmed by common classes, but at least now you're basically able to get a bucket where you're still pretty likely to not lose most of your rare classes. So sometimes there's a twist in the problem you can do there to help with that. Those are, I can't promise you that'll work, but sometimes if you like give up on total automation and accuracy, there's still other ways that AI can be useful. I don't know if that motivated you or just gave you ideas to think about, but like, I don't know who asked that question, but let's make sure, like, I don't know, buy them a fancy coffee. I don't want them to be sad.
I think the version of this, Dan, that maybe was really eye-opening for me, we were working with people at Idaho Department of Fish and Game, and it kind of, species classification was still like a class average accuracy was still really low, but you could tune these models so that you could pretty much trust if the model identified a deer or an elk, or like, I don't know, like a cow, maybe like that species list is slowly growing, but the ones that where it's like, if we use a pretty high confidence threshold on these pretty common species, we pretty much can trust that the model's correct. We're not missing a lot of rare stuff. And then it's just, now you can filter out all the empties, you filter out all the common species, and now you're left with maybe 5% of your original data, and that's like what a human reviews. And there's going to be some deer in there, there's going to be some empty images, but there's also going to be the rare stuff they care about, hopefully. But you can't make necessarily guarantees. So you have to kind of think about, like, what does it really mean if you miss a single rare species? For example, with bioacoustics, like that project in Oregon. No worries. With bioacoustics, that project in Oregon for spotted owls, like if they miss a spotted owl, they would be very upset, kind of like the Endangered Species Act. If you miss the thing that is going to kind of generate funding for your organization, like that's bad. So you could still then say, okay, I want to look at everything that has 0.1% confidence or higher that it's a spotted owl. Oh, hey, Dan. What up? Except now we can't hear you, unfortunately. And maybe that's going to be, 1,000 examples, but if you looked at everything, it would be 1 million examples. So you might still need to do a lot of work, but you can do a lot less work. Does that make sense?
Makes sense, yeah.
So think about the problem instead, like how do you save the most human time in a way that's reasonably reliable? And how do I build metrics that capture the things I care about so I understand how much time I'm saving? Am I missing the things that people are going to be really upset if they miss? Can people actually choose based on their own research problems and their own interests, like what operating threshold to use? Like, actually, I cannot miss any rodents on my islands at all because that is locally ecologically devastating. So I'm maybe going to have to review even more data, right? But that risk, I guess, becomes a factor. No, we still can't hear you, Dan.
It's muted.
Well, he's muted on his phone, but if he turns his phone, what if you mute your computer, Dan, and then turn on your phone audio? Okay.
Can you hear me on my phone now? I have no idea why my computer mic's not working, whatever. And also I would now double back. So again, I don't want to discourage anybody, but also remember that sometimes AI isn't the right solution. And if your B case happens to be the case where it's like, it's actually impossible to tell the rare species reliably enough to make it useful, don't be afraid to say, we learned a bunch, AI can't solve this problem, or we'll check in again in 2029. But that's sometimes the best advice you can provide to an ecologist.
Mm-hmm.
That should have been, oh, that sounds inspiring. Your problem is hopeless, forget about it.
See you in 2029.
At least that means humans are still needed for some stuff.
Yeah, I actually think humans are still needed for everything. So maybe that's a personal opinion. All right, Dan, do you have a slightly more positive message to finish us off on?
Yeah, I guess the flip side of everything I just said is the part of the talk we didn't get to today, the part that Sarah just got to see, my whole ESA talk, that the flip side, sometimes we actually set the expectations way too high for what AI needs to be before it can be useful. Again, don't get so hung up on accuracy. You may be doing better than you think. If you get to 78% accuracy and you were hoping for 95, don't bang your head against the wall too long to try to get from 78 to 95. Take a break and think about, well, is there a creative and clever way that 78% accuracy can be useful to the community? Can we get the ball rolling here? Maybe get some more training data that way. So don't set the bar too high. Often people really, it is so intuitive to be automate or bust. It's never automate or bust. So actually you may already be doing better than you think is my semi-inspiring message.
Yeah, and then there's been some recent papers in the last couple of years where they've done things like taken human labeled data and run an occupancy model over it, taken AI labeled data that has corresponding to that human labeled data, maybe only like 75% accuracy, run an occupancy model over the predictions of the AI, and the occupancy models are the same, pretty much. So like, actually, why don't we evaluate the thing you actually want to do and see if you need, like, what accuracy do you need in the predictions to get like sort of the ecological information out that you want. The assumption that humans are right all the time is just wrong, right? Like my camera trap data sets that I get from ecologists will be like 10% wrong sometimes. So
along the same lines, when I started working in the space, especially with camera traps, coming from a machine learning background, it was so intuitive to try to, it was really important to get really close to 100% accuracy. It's really helpful to be reminded by ecologists that the sources of noise and error they are working with, what if they're trying to do a deer population survey, the randomness of whether a deer happens to walk by your tree or whether a bird happens to make noise near your microphone is so high that sometimes we're actually working ourselves up too much about machine learning accuracy if we really factor into the grand sources of like the statistics they have to do to estimate populations or occupancy from the noisy inputs they have in the first place are often large enough that we don't need to get ourselves too worried about being every % accuracy on the machine learning side.
Yeah, we're like thinking about the way the errors propagate downstream. So false positives for a lot of downstream ecological models are much more detrimental than false negatives. So actually, if you're missing some of those rare species, that might have less of an effect on your downstream analysis than if you accidentally predict something rare where it doesn't exist. What were you going to say?
I think you could get at that ahead of time with simulation.
Yeah.
You know, like looking at like what you were just doing, like how badly do I have to muck up the data from the, you know, from the observation process from the occupancy model to get the same result, and then maybe you would have this threshold way below 95 where you would, you know, where you find something acceptable. So like thinking about your end result and like working backwards. I
would love to see papers like that. So that would be very cool because I don't feel like I've seen it as much of this understanding of like how accurate do my occurrence records need to be, like conditioned on the data I've sampled to get sort of the same analysis in the end or same inference in the end. I would be fascinated. So please write that paper.
Ooh, while we're talking about papers we want to see more of, especially for all those of you who are working in a university environment, I would love to see us start. Again, as you can tell, my theme is like focus a lot on how you can make people more efficient and save time. And that is every bit as much like a human factors question as it is a machine learning question. I know it is very difficult and impractical sometimes to conduct human factors studies, but it's really important. And we're just starting to see a couple papers doing that. And it's often a great way to like go out and reach out to your computer science colleagues who may be in HCI and trained in usability analysis to ask questions like that. And there's really interesting papers for both departments to write there about like, I trained my AI model to be 79% accurate, which maybe I wanted 95. Again, can we do a human factor study now to ask, well, how useful is 75 versus 95, and is it worth the extra hassle? We're only just scratching the surface in those kinds of papers in the literature.
Yeah. Awesome. Okay, let's all thank Dan. Thank you so much. All right.
See you later.
See you, Dan.